Okay, so the last video that we'll do in this section is finding measurements of rhombuses and kites. And so we're just doing a few more examples here of what we've done before. All right, so recall that the area of a rhombus or a kite is going to be equal to 1/2 times the diagonal 1 times diagonal 2. Okay, so having that said, it looks like they actually give us both diagonals, right? Diagonal 1 they said is this, and diagonal 2 is this. So these are our important values, and our units are in centimeters. So I'm just going to say that the area is equal to 1/2 times our diagonal 1 is 8x plus 7, and our diagonal 2 is 14x minus 6. Okay, now here's something that pops up where if you weren't paying attention in algebra class, this is going to be rather difficult. Okay, we want to do the FOIL part first. Okay, so we'll leave the 1/2 alone, but we'll FOIL the other two binomials. So our area is going to be equal to first times first, so 14x times 8x, okay, is going to give us 112. It's going to give us 112x squared. Okay, the outside part will give us 8x times negative 6 will be negative 48x. The inside part is 7 times 14, so 7 times 14 gives us 98, so a positive 98x. And then last times last year will give us negative 42. Okay, when I combine like terms here, I get 1/2 times 112x squared plus 50x minus 42. Okay, now when we distribute this 1/2 throughout the entire equation, okay, 112 divided by 2 gives us 56, so I now have 56x squared. Half of 50x is 25x, so plus 25x, and half of 42 is 21. Okay, so our area in this case is going to be all of this trinomial here, and it's going to be square centimeters. It's going to be our final answer. Okay, so again, some prerequisite knowledge there that if we didn't have, maybe that one was slightly more difficult. Okay, but that is the algebraic representation of our area in this particular case. Okay, let's look at another one. Okay, it says find the area of this kite. All right, this problem's a little bit more involved. Okay, and here's why. It doesn't actually give us the measurements of either of the diagonals. Okay, we do know that first of all that these are all right angles here. Okay, it's important to understand that those are perpendicular, so they're all right angles. Okay, but we have to figure out x and y. So the first thing I'm going to do is maybe take a look at let's see, I know that's 28. Maybe I'll try to figure out y first. Okay, because I know a hypotenuse and a leg here, and I can figure out the other leg by using the Pythagorean theorem. Okay, so I'm going to say that I'm going to find y, and I'm going to do all this work in green. So you can take, that's kind of how I'm going to organize this. So I'm going to say that y squared plus 28 squared is going to be equal to 35 squared. Okay, and so I'm going to grab my calculator here and figure out what 28 squared is. 28 squared is 784. So y squared plus 784 is going to be equal to 35 squared, which is 1,225. Okay, I'll now subtract 784 from each side to get y squared is going to be equal to 441. And I'll take the square root of each side to find out that my value of y is 21. Okay, so that certainly helps. Now I have y. Again, I know that this is 21. I'm just going to write over that. Okay, so again, that's certainly helpful to understand that. Okay, let's look and see if we can find x now. Okay, so since we know that one of the legs of this triangle, let's call this maybe the blue triangle now. Okay, we know one of the legs of the triangle, and we know the hypotenuse of the triangle, and we need to find x, right? So it's basically going to be x squared plus 21 squared equals 29 squared. Okay, so 21 squared gives us 441. 29 squared gives us, let's check the calculator here, 841. Okay, and this is x squared still. So if I subtract 441 from each side, I'll get that x squared equals 400. and if I take the square root of each side, I'll find that x equals 20. Okay, so I'm going to write 20 right here. Okay, and let's see, the last piece of information that I actually need to know is that with these consecutive sides, I guess, this is, if by definition of a kite, this is 29 and this is 35 over here. Okay, and so by definition here, that this actually has to be equal to the same, right? And so this is actually 21 over here as well. Okay, and so really what we figure out at this point is we figure out that we can find the area of this entire thing by using our formula, right? So we know that our formula is the area of a kite is going to be equal to 1/2 times diagonal 1 times diagonal 2. So in this case, that'll be 1/2 multiplied by diagonal 1, let's call it 42. Diagonal 2 by the segment addition postulate will be 48. Okay, so if I plug all these numbers in, I take, again, 1/2 times 42 times 48 is going to give us 1,008. So our area here is 1,008 square inches. Okay, and that will be our final answer. Okay, let's see if they've got one more for us here. Okay, the final one, it says find diagonal 2 of a rhombus in which diagonal 1 equals 3x meters and the area is 12xy square meters. All right, so let me see if I can go find a rhombus here. Okay, let's see. Rhombus, this one looks good. Okay, so I'll take a rhombus here, and it says the area is 12xy meters squared. Okay, and diagonal 1 is 3x meters. So I'm going to take a line here. I'm going to change the color actually a little bit. Okay, and they said that was, again, 3x meters squared, right? And we want to know what diagonal 2 is. Okay, so we'll just use our formula that, the area is going to be equal to 1/2 times diagonal 1 times diagonal 2. Okay, so this time it's going to be 12xy is the area. We use 1/2 from our formula. Okay, diagonal 1 says that it's 3x meters, so I'll put 3x, then multiplied by diagonal 2. Okay, I'm going to use that trick from last time where I actually just divide both sides by x, and that will give us now 12y equals 1/2 times 3 times diagonal 2. Okay, now I'll just kind of simplify this a little bit. So 12y equals 3/2 times diagonal 2. Okay, at this point I will multiply by the reciprocal. Okay, I'm going to scroll down a little bit here. So I'll multiply by the reciprocal to get rid of these fractions. Okay, 2/3 times 3/2 will multiply to 1, so I'll find out that diagonal 2 is going to be equal to 36 divided by 2, which is now going to be 18y meters. Okay, and that will be my final answer. Okay, so again, at this point, I hope you guys feel confident to go forth and try your homework and ask me questions in class.